Okay, hello geometry students. I am going to be looking at Fry's quiz over biconditionals and deductive reasoning. And I also have a student online here with me, so there might be a question or two that pops up while I'm going over this. I felt like I'd, kind of take care of two things at once, talk to him about it and read it over with him at the same time. So. And one thing I'll do is after this video, after I post it, I'll come back over things for you. Here we go. The quiz over biconditionals and deductive reasoning. Number one, what two things do you need in order to write a biconditional? So a couple of the things that you need to write a biconditional. So you need to have some sort of statement, and then you need to have its you need to have the opposite of that statement, or not the opposite, but the kind of in reverse. Okay, so there's a couple ideas for your number one. Number two, if you have a good definition, it should also be able to be written as a what. And once again, that word that we need there is going to be defining, what the opposite, or in reverse. I keep saying opposite. It's not really opposite. We're not saying not. We're saying the phrase in reverse. So what is that? Make sure you're using your notes with this too, and you could pause this video as we move forward, because I know I'm going kind of quickly through it. But just to give you an overview, if you want to listen to this and then come back to these two, you could take some notes and then come back and then answer them and review the video too. For number three, if the following statement and its converse is true, write it as a biconditional. So you're just going to put in, remember, biconditional is going to be if and only if. I know that's sloppy, but it's because my paper was kind of up, but if and only if statement, okay? So if two congruent segments have the same length, then they are congruent, okay? So think about that. If they have the same length, well, yeah, that makes them congruent. So you can do an if and only if statement there. So, how would you change that phrase? And how would you make it into an if and only if statement? If and only if is going to go in the middle there, kind of where that comma is. And then you take the if and then out and put if and only if. Number four, write the two statements that form the following biconditional. So you're going to break this up into the two statements that make it a biconditional. So an integer is divisible by 100 if and only if its last two digits are 0. So you want to take that if and only if out of there and then write those two statements that make that biconditional, okay? So you might want to write it, remember, for a biconditional, it has to be in reverse too. So you got to write that, that reverse statement also there for number four, So you're writing the conditional and you're writing the reverse. So it's going to go both ways. Remember the biconditional, the symbol. If I can write this, remember you had your P, your hypothesis, and your conclusion, Q, and but it went both ways. The arrow went both ways, so it can go backwards or forwards. That makes it biconditional. All right, this one's really confusing. Number five is really confusing because you have a law of detachment and a law of syllogism going on here. So you have two things going on. So for number five, if you live in the Bronx, then you live in New York. Tracy lives in the Bronx, then she lives in where? So you would rewrite that, and that would be your example of law of detachment. Okay? And in the directions, you are to use the law of detachment or the law of syllogism to make a conclusion. Or if not possible, to use either, right? Not possible. If you used a law, make sure you state which one. So right there we used one as you finish this first part. So he has another thing going on here, which I think he just put two together at once. So forget about Tracy for a moment. If you live in the Bronx, then you live in New York. If you live in New York, then you live in the 11th state to enter the Union. So you're going to rewrite your P to R. So remember, this is the P, and this is the Q, the conclusion, and then you take this conclusion, and it goes to another conclusion, which we say is R. So P goes to Q, and Q goes to R. So now just go P to R. So P, you would write this section, and then R, you would write this section, and that, remember, is the law of syllogism. Okay, so you write law of syllogism. So you have first one, the law of detachment, involving Tracy. If she lives in the Bronx, then she lives in what state? You would write that there. And then you would write law of detachment. And then for the second part of the number 5, you would rewrite this with P to R, and you would write law of syllogism. Okay. For number 6, if a student gets an F on their final exam, then they fail the course. Emily got an F on her final exam. So what happened to her? What did she do in regards to the course? Rewrite that. That would be a law of detachment there. Okay? Okay. Determine if the following are good definitions. If not, explain. So a cat is an animal with whiskers. Okay, so let's try that backwards. An animal with whiskers is a cat. Is that a good definition? Explain why not? I mean, do we have other animals with whiskers that aren't cats? Think about that one. So number 7, explain that in your own words. Number 8, perpendicular lines are 2 lines that intersect to form right angles. Okay, so read it backwards. 2 lines that intersect to form right angles are perpendicular lines. Ooh, that sounds good. So, if not, explain, but if it's good, you're just going to say it's good. So, there you have it for number 8. Hopefully this helps, and good luck with this. Is it a test or a quiz? Quiz. Good luck with this quiz.